Our favorite time of the day where we connect with Dr. Chris Smith, our naked scientist, and he's the chair of science at University of Cambridge, and he joins us every week to talk to us about any science-related questions. Good doctor, welcome to the show.
Happy New Year for what's coming. Did you have a pleasant Christmas?
Yeah, so I was invited by a friend, a young family like ours, and we went to a place out in the Valvereeniging, and we just spent the day there. We had a simple brine and went back home. So it's really been chilled with what is happening in this country. There's nothing that is going to say to you, go to some, I don't know, packed place and risk, contracting COVID. So we've been taking it quite easy.
Yeah, well, same. Most people here have taken it easy, and
Great stuff.
where previously there was going to be this sort of 5 days of revelry to remind everyone that we still exist as human beings, that got curtailed and turned back into one day of exchanging jollities, except for some people in certain parts of the country where it was basically one household. But it is pretty grim at the moment, actually. In some parts of the country, we've got hospitals very, very busy again. In fact, as busy as they were when this all kicked off back in March and April. And we've also had big, exciting news of the South Africa variant that you kindly sent us. And we've been sending our variant to a few other parts of the world as well.
Yep.
Very interesting times.
On top of that, you guys are dealing with Brexit, but we won't go in there. So now, yesterday was a little bit busy for me, doctor. And this morning, as I was coming to work, I thought I needed something to pick me up. And this is my question to you as we kickstarted this segment. And I thought, let me just get myself an energy drink. It was a little bit too hot, so I didn't want to have coffee this time. So I thought, let me just have an energy drink. And I got chastised as I walked through the door at work. People telling me how bad the energy drink is. For your health, particularly for your heart and so on and so forth. And I thought I should just, kickstart this and ask you, what is in these energy drinks that we drink? And, some people would need 2 cans of the same energy drink to get a little bit of energy, while someone maybe will need like half a can or something like this. How does the whole energy drink thing work in our system?
Does a couple of things. Number one, there's a very big hit of sugar because there's a lot of energy in the form of sugar which is packed into these drinks, and they give you a really big metabolic kick up the backside because sugar is very easily absorbed into the body and it's in a form that cells can instantly use. Doesn't matter what cell you're talking about around the body, any cell can burn sugar, and so cells love sugar. The other thing it does is it contains a really hefty dose of caffeine. And caffeine, the same stimulant that's in tea, it's in coffee, it's in Pro Plus, a range of other products. Caffeine works in a range of different ways. One of them, to give you a real boost, is that it potentiates the action of adrenaline in the body. Because what it does is to inhibit an enzyme called a phosphodiesterase. And phosphodiesterase breaks down various signaling molecules which are produced when adrenaline binds onto your cells. So normally you have this enzyme there and it switches off adrenaline, so you minimize the stimulus you get from an adrenaline hit. But when you've got caffeine on board, it inhibits that process, so the adrenaline signal is felt more potently. And so that's a big wake-up call, metabolically speaking. The other thing it does is it gets into your brain, and in the brain you feel sleepy because over the day a chemical called adenosine builds up. And as the adenosine builds up, it basically sends a sleep signal to the brain. So this thing called sleep pressure increases. And when you go to sleep, your brain resets the system and flushes away the adenosine, and then you wake up feeling not sleepy again. If you load your brain up with caffeine, it gets in the way of the adenosine so that the brain doesn't see the adenosine building up. So you feel less tired than you really should do. Now, these effects are all something you can become tolerant to. So if you get used to running a very high caffeine level, then your body resets the system a bit to balance things out so that you are normal when you've got that high caffeine level and abnormal when you don't. So some people, if they drink a lot of tea, a lot of coffee, or use a lot of these energy drinks, will find that they feel profoundly abnormal if they don't have them. And they actually can crash a bit and they have headaches and they feel very, very lethargic and sleepy. And then they have one and then they think, wow, what an amazing pickup that gave me. These energy drinks really work. I was feeling really tired until I had that. And actually what they've done is to basically take away the withdrawal symptoms of not having enough caffeine in your body and made you feel normal. So there's a fine line between a little bit as a pick-me-up now and then and a bit of a buzz from having a strong coffee or whatever, which, we all do that in the morning. It helps us get going. And being very, very tolerant to these things because you use a lot of them, and then they can actually disturb your sleep. They can encourage you to do more than you should do without taking proper rest breaks. And as a result, when you do take that stimulant away, you feel really pretty dreadful, actually. So don't overdo it. Use them recreationally for when it really counts, or when you do have to, really need a pick-me-up, or just to give you a bit of a boost now and then, but don't do this habitually just to get through a hectic day, because you'll do it day after day after day, and then you really will crash.
Great advice. Dennis in Fourways, your question for the good doctor?
Okay, thank you, sir. My question is, knowing that the planets together with the sun in our solar system are in one plane, the question then is, other solar systems within our universe parallel to each other? What actually gives our universe the geometric form that it has? Thank you. I'll listen on the radio.
Thanks, Dennis. Doctor?
Oh, lots of important questions wrapped up in what seems like a suspiciously simple question. First of all, why are all the planets on a flat sheet across our solar system? Why aren't they going around in all random directions? And the answer is that when the solar system formed, an enormous gas cloud collapsed in on itself to launch the proto-star that became the Sun. Some of that gas and dust aggregated in a big shroud around that star, but because of the effects of gravity, it would have slowly accreted into a disk because of the way that, in fact, the gravity works out, and the way that the spinning star in the middle would have been slightly fat around the middle, slightly thinner at the tops, and that would have meant that the gravity field that was established would have pulled the material down into a flat disk around that forming star. That disk then formed baby planets, and baby planets formed bigger planets because gravity within the disk pulled material in each area into a planet. So you get basically all the planets where that disk once was, except that the material that was spread out like a disk is now concentrated in the planets. But obviously other local factors can come into play if things hit each other, bash things out of the way, or get launched into weird trajectories after all that's happened. Then you can get things orbiting slightly off the plane. But that's the way it worked in our particular system. Remember that in other parts of the galaxy and then other galaxies, then there will be things at different attitudes and angles to each other. But the bottom line is that there's a push-pull going on because the universe is growing all the time. It's growing and it's getting bigger because of dark energy pushing it apart. And it's also trying to shrink because there is gravity coming from dark matter, and also the matter we can see, dark matter being the dominant one. And that's a push-me-pull-me thing. So on the one hand, you've got the universe getting bigger on a grand scale, and the galaxies are racing away from each other because the space between them is getting bigger, because dark energy is creating more space, and as you make more space, you make more dark energy, so the whole thing's accelerating. But locally, you've also got lots of dark matter, gravity, and things being pulled in together, and that is causing, at some levels, things to be moving together, at other distances, things to be moving apart. And this is all down to the push-me-pull-me effect of those two factors, driven by the initial Big Bang that spawned the universe back 13.8 billion years ago in the first place, that got things going, pushed things apart, and then after that, the random fluctuations in where matter and particles were, and then their mass and gravity helped to pull things into the shape that it then adopted.
Now I understand what you mean when you said it's a very complicated issue, but thanks for explaining it to us and making it so simple. Keith and Ethel, welcome to the show.
Hi. A quick one for the doctor. Now that you're vaccinating in the UK, I just wanted to find out, do they actually test people before they give them the vaccine to find out if they're positive? And if you don't test and you have a asymptomatic patient, but they've got the virus, but they're not showing any symptoms, what effect does the vaccine actually have?
Great question.
Okay, the
Thanks,
answer
Keith.
is that we're not testing people before we vaccinate them, either for evidence they've got the infection right now or that they have had the infection in the past. So, in other words, prior infection or present infection is not a contraindication to having the vaccine. And the reason is a simple one, and that is that the vaccine is there merely to stimulate your immune response. Well, the virus infecting you will already be doing that, so all you're doing is making the immune stimulus a bit stronger, which should help you to fight the thing off a bit better. The other possibility is if you've had the infection before, we don't know what the long-term lifetime of that immunity is. It looks like it's maybe 6 months or so based on a recent paper in the New England Journal of Medicine that looked at people getting the infection again after a certain period of time. So therefore, if someone has had the infection before, they may not be protected for as long as if they have the vaccine. So therefore, giving the vaccine on top of previous exposure to the virus will only reinforce the immune response and make you immune for even longer, again, without negative effect, as far as we know. So at the moment, no one's testing people apart from unless they've got symptoms on the day, and in which case they shouldn't be coming in to have a vaccination. But no one's testing people and then using that to decide who should or shouldn't be vaccinated at the moment. We've got a pecking order. In most countries have a pecking order based around who's at highest risk first, and then trickling down that list to lower and lower risk groups, and that usually means by age.
Rueda from Ondeggers Park. Chris is listening.
Good afternoon, Chris.
Hi.
I want to know what happens if we take in too much of these vitamins. I'm on a very powerful multivite. Now I'm being told take more vitamin B2, C, D, zinc, cloves, whatever. What happens if we have an excess of these things in our body?
They can be quite harmful, so you should never overdose on vitamins. Some vitamins are fine, and those are the ones that are water soluble. Because if you overdose on a water soluble vitamin, you basically just make very expensive urine. So vitamin C, for example, if you overdosed on vitamin C, you just pee lots of expensive vitamin C down the toilet because it dissolves in the blood, and anything that's at a high level in the body gets filtered out by the kidney and goes down the lavatory. The ones that are more of a concern are the vitamins that are fat soluble, because they dissolve in the body fat, and then you can have chronically high levels of those vitamins and they can have untoward effects. Good example of that, vitamin D. If you have too much vitamin D, it can actually promote high levels of calcium, and this can start to fur up parts of your body in the same way that high levels of calcium in drinking water will fur up your kettle and your geyser. So therefore, don't overdo vitamins. Vitamins are molecules or chemicals that are needed only in tiny amounts to keep the body healthy, and any more than a tiny amount is a waste and potentially health harmful. Good analogy for this, your car. Your car engine needs a small amount of oil in it to run smoothly. If you put too much oil in it, it doesn't make the engine run any better, and it can, under certain circumstances, actually do harm. So a little goes a long way, and the same is absolutely true for vitamins.
Here's a follow-up question to the issue we started the conversation with Dr. Chris on energy drinks.
Good afternoon, Chico. It's Edward here. Would you please ask the scientist as to how true is it that if you take a lot of energy drinks, you will indeed develop diabetes? Thank you.
Well, it's not so much the energy drinks per se that are causing diabetes, but the lifestyle that goes with the energy drinks. People who need energy drinks are probably people who are not sleeping properly. And we know that people who are not sleeping properly are more prone to indulge in the wrong sorts of foods. And by wrong sorts of foods, it's the kinds of foods that we would normally advise people to save for having a treat. So things which are very high calorie, very high fat, very sweet. Those are the kinds of foods we crave when we get very tired. And that's probably because when you're very tired, A, your resilience to say no is lower, but B, your body is saying, I need energy, I need it quick because I feel so tired, just feed me that stuff. And because you take on board far more than you need, you tend to gain weight, and gaining weight is the biggest risk factor for diabetes. It causes so-called type 2 or maturity onset diabetes. It's because when we become too weighty, too heavy, you become resistant to your own insulin. The insulin that you produce doesn't produce a powerful enough effect in the body to adequately control blood sugar. So given energy drinks are part of that lifestyle of probably not getting enough sleep, probably eating the wrong things, and therefore that all contributes to weight gain, it's through that route that the energy drinks, the lifestyle, and they do contain a lot of sugar. That's not going to help. It probably will promote a higher risk of diabetes. But you can't say the energy drink causes diabetes because that's a different issue. And someone who drinks an energy drink isn't going to immediately get diabetes. It's the lifestyle that probably is what ensuing leads to a higher risk of a range of health problems, actually. So, as I said earlier when we were talking about this, use these energy drinks for fun, recreation, and when you really do need a pick-me-up, used occasionally, they're not going to do any harm whatsoever. As part of a lifestyle to support a very hectic, frantic, unhealthy lifestyle and make that possible, like any drug can be used to make those sorts of lifestyles more tolerable, it doesn't mean it's healthy in the long term. So, don't do that.
Yeah, don't overdo it. You're listening to the voice of the naked scientist, Dr. Chris Smith. Can send us a WhatsApp message, 072 702 1702. And here's one.
Good afternoon, Sergio. This is Utumelengad in Western area. My question for Dr. Chris is, I'm always intrigued when I look at the videos and the pics of people swimming in the Dead Sea. They automatically floating. My question is, what's in the water that makes you automatically float? You don't even need to swim your way up. You just floating on top. And I find it so intriguing that people could just read newspapers while they're floating. Thank you. Nice show, Sergio. Sharp.
You're welcome. Sounds like an ideal situation, Doctor.
Yeah, I always wanted to go and do that too. I used to gaze longingly at the telly at these people who are drifting around on the Dead Sea with a newspaper and think, I'd love to do that. The reason is that the water is very salty, and when the water has lots of salt dissolved in it, the density of the water is much higher. And the reason that anything floats on anything else is that the thing that is less dense floats on the thing that is more dense. Your body contains salty water, so when we go into a lake or a less salty environment, we tend to just about float because the salty water in our body is almost balanced by the salty water that we're in. But remember, there are other bits in our body that are even more dense, like bones, for example. So we tend to have a slightly higher density than fresh water, so we want naturally to almost sink. But if you dissolve enormous amounts of salt in the Dead Sea, in any sea or in water, the density goes up because density is equal to mass divided by volume. So if there's something dissolved in the water, the mass is there, so the water weighs more. If I took a litre of Dead Sea water and a litre of water out of a pond, you'd see that the water, it's the same volume, but it weighs a lot more, has a much greater mass from the Dead Sea because of all the salt that's in it. Therefore, its density is a lot higher and you will naturally float on it because there's more water pushing back up on you. When you try to sink, you push a bigger mass of water out of the way with your body, and therefore there's a bigger mass pushing back on you. That's the buoyancy force, so you are supported in the Dead Sea. And the reason the Dead Sea is so salty is because it's not connected to the rest of the world's oceans. It's effectively a landlocked lake, and rivers flow into it. They deliver minerals which are washed out of the soil and the mountains by rainfall. They congregate at the Dead Sea, and because it's hot, the water evaporates, leaving behind a very concentrated solution which can't be replaced until the rivers add more water, but they're adding more salt all the time. And so it's got this very, very strong salt solution, very, very dense, very buoyant.
So if I had too much money that I didn't know what to use it for, and I send a huge container to go get some water from the Dead Sea, and I transport it back to Joburg, and because I want to start my own artificial Dead Sea resort, would that work at all?
You'd have to move a lot of water. It would probably be easier to get them to send you a very small sample, put it into an analyzer, work out what chemicals are in there, and then just recreate the Dead Sea from the chemical ingredients, because you could easily do that. And then you could make as much Dead Sea in Joburg as you wanted. One interesting other thing is next time perhaps people are off to Durban or something, go when you're next to the port or down in Cape Town, have a look at the port, look at the ships there, and you'll see markings on the side which are almost like someone's painted a ladder up the side of a ship with a round circle in the middle of the ladder. And this is called a Plimsoll line, after Plimsoll, the man who invented this. And they realised a while ago that ships could carry a lot more cargo on the sea than when they were going into a river. Rivers contain fresh water. On the sea, it's salty water. Therefore, the salty water in the sea is much more buoyant than the water in the river. So if you overload your ship to the point of almost sinking on the sea, and then you sail it up a river, because it becomes less buoyant in the river, it will actually sink when it gets into the river. So they had to actually make adjustments for how much cargo a ship could hold, depending upon which bits of sea, which waterways, or where in the world it was going to navigate, because all of these factors, as well as the temperature of the water, makes a big difference. And that's what the Plimsoll line, that funny ladder pattern up the side of the ship, is there to indicate.
Fascinating. Mutusi in Pretoria, welcome to the show.
Yeah, welcome, Doctor. I just want to find out, Doctor, a body was infected by COVID and the body died. Does the COVID continue to affect the body even though it's dead, or when does it stop?
Thanks for the question.
It will grow for a little while longer, because when you die, your cells don't all instantly die all at that moment. Your body as a human being ceases to function because the organs are no longer all working together. But it doesn't mean all the tissues are instantly deactivated and dead, and therefore some tissues continue to remain viable for a short time after death, and therefore the metabolic processes that allow viruses to grow in those cells will continue for a short time after you die. But whether a person is infectious when they've died is more to do with how stable the virus is in the environment. Now, some viruses are very stable, and therefore they will hang around in the environment or on the surface of a body for a really long time. Other viruses are much more fragile, and they will deactivate quite naturally, quite quickly. The main route of transmission for coronavirus is respiratory spread, which means when a person is alive and symptomatic, they are breathing. As well as breathing, they can be talking, shouting, singing. They may also be coughing and sneezing. All of these respiratory manoeuvres blow a fine shower of tiny droplets out from their airway, and if the virus is in the airways, it will be packaged up into those droplets and blown out into the room. When a person passes away, then they're not going to breathe anymore, and therefore they're not producing or expelling from the body respiratory droplets in the same way. So the risk of infection from a person who's died from coronavirus is much lower than when that person is alive and symptomatic. But with other viruses, that's not the same situation, because other viruses may leave the body in other routes or via other routes or be in other body fluids, and therefore different practices and different ways of safeguarding against infection need to be observed. It's not just a one-size-fits-all.
Quick question before we go to Soli out in Pretoria, Doctor. Organs that stop working when someone has passed on, do you know which is the last one to stop working?
Well, the organs which are most vulnerable are going to be the ones that have the highest metabolic rate. Those organs are the ones which are most vulnerable to the cessation of blood flow, because quite quickly they're going to run out of oxygen because there's no blood bringing them fresh oxygen, and they're going to basically stew in their own juices and die surrounded by their own waste. And so things like the kidney, the brain, the heart, very, very vulnerable to not having enough blood supply because they run out of oxygen and sugar. Other organs which are much less vulnerable will be tissues which have a very low metabolic rate and therefore will remain viable for longer. Skin cells have a lowish metabolic rate. The skeleton has a lower metabolic rate, not zero, but a lower metabolic rate. And don't forget that your body has more bacterial cells in it than it actually has human cells in it. And the bacteria are much more resilient. So that you'll be able to recover bacteria from a person who's died a long time after they've died, because as soon as the person's died, the bacteria in them then begin to eat the person they were living in. And that's why we break down. So I'd say that the most robust and resilient cells in a dead body are the bacterial and fungal cells that are busy eating it.
Wow, interesting. Soli in Pretoria, thank you so much for staying on the line. Your question for Dr. Chris?
Thank you, and good afternoon, the doctor and Tshego. I just want to find out, this is to me rather fascinating, that I know that the Earth is rotating around the sun on its orbit and sort of hanging in space. I just want to know quickly, what holds the Earth in place? Why is it not floating away, into, shall I say, oblivion? And, regularly it will go along its path and rotate around the sun. It's in place at 156,000 kilometers per hour, very fast speed. And this happens every day. What holds it in place? Why are we not falling away? Thank you very much.
You're welcome.
Well, some would say we are falling all the time, but we're falling in a circle. And we're in an orbit around the sun, falling towards the sun all the time and missing the sun, but we are continuously falling. That's what gravity is. The sun is massive. It's huge. And with that sort of mass, you have a very powerful gravitational effect. So the sun is bending the fabric of space around it so that we are, as we try to move in a straight line, we are continuously being curved as we travel through bent space towards the sun. So we go around in a circle. That's what gravitational attraction is. So the Earth is trying to move in a straight line but being deflected all the time in a circle, as are the other planets in our solar system, the asteroids in the asteroid belt, and then the material that's even further than the observable solar system in the Kuiper belt, and then beyond that into the Oort cloud. That's our solar system. So it's all down to gravity and the fact that our bodies in our solar system already have momentum. They're moving, but gravity is deflecting their course and keeping them in an orbit. And our solar system's existed for probably about 5.5 billion years, and so it's had time for the system to stabilise and get into a pattern that is gravitationally stable, holding it where it is today.
And last question, Doctor, before we go, we've got about a minute to go. And this one comes from Faith. She says, please ask the naked scientist how I can safely dispose of red poison. Must I burn it or flush it down the drain?
Well, be careful about flushing anything straight down the drain because A, some things might not take kindly to being mixed with water in large quantities. B, it might play havoc with certain sewage systems. If people have got biodigesters or chemical toilets, there could be nasty interactions. The best thing to do would be to look at who has got a local chemical disposal service near to you and ask for advice. They will probably safely take that off your hands and dispose of it safely. The key thing is to make sure it doesn't fall into the wrong hands because obviously if a kiddie picks it up or something, they'd end up being poisoned. So be very careful with it. But please, no, don't chuck that down the toilet. Seems like a simple solution, but it could play havoc with where it ends up at the sewage works or in someone's chemical toilet. So please don't do that. Yeah. Please take advice from who your local safe disposal service is.
Dr. Chris, that's why we're going to have to leave it. Thank you so much for your time again this week. It's the voice of Chris Smith, who's our naked scientist. That brings us to the end of the Azania Mosaka show with me, Tseho Mudisani. It's 3 o'clock.